Okay, welcome to video 2 of the cardiovascular system. Once again, I mentioned this in the first one. It's kind of random, it's kind of scattered. You're going to see this over the next couple of chapters, but we're kind of highlighting on certain things. Man, I tell you what, if time was limitless, I would love to just go on and talk about, I can talk about these next couple of topics. I can talk about those for 30 minutes a piece. It's just incredible. But we got to keep our flyby going so you can get all these different things. So once again, the amount. Let's go with this one. Okay, the amount of blood ejected by the left ventricle each minute is calculated by what formula? Okay. Now, this is the good thing about watching this tape the way we're doing it. I know when I took human anatomy, we were just responsible for everything in the chapter, and it was crazy. It was absolutely crazy. The good thing about this format is you can stop that tape, you can write these things down, you can take notes, you can even listen over the tape a few times to help you. But remember, there could be other things that I talk about. You're responsible for things in the chapter, but for the most part, we're going to try to test you on things that we really zeroed in on, which is a big plus for you, because that chapter is incredibly full of information. So what are we talking about here? The amount of blood ejected, meaning put out, of the left ventricle. Okay, once again, let me make sure I have this right. The amount of blood ejected by the left ventricle each minute is calculated by what formula? The formula is heart rate times stroke volume. Okay, so you calculate how many beats per minute you have, and when we say stroke volume, it's however much comes into your heart, okay, times the number of heart rates. So it tells you how much blood leaves the ventricle each minute. Now, the three factors that contribute to arterial blood pressure, okay, all right, so what are the three things that causes your blood pressure, all right? So first of all, there's cardiac output, how much blood you're pumping out, okay? Blood volume, how much blood is in your system. Ordinarily we have the 5 liters, okay? And then, okay, the third factor that determines blood pressure is the resistance, okay? So there's 3 factors that determine your blood pressure. The cardiac output, okay, all right, how much blood is pumped out, okay, then the volume of your blood in your body. But then what do they mean by resistance? Resistance is if you've ever had a garden hose, okay, and you hook that garden hose up to your faucet. If it's a big old thick garden hose, you turn that hose on, and a lot of water is coming out, but it doesn't look like very much. It's just a steady stream of water, but a lot of water is coming out. Then you take that same faucet and you put this little bitty hose on it. Okay, you put a little cheap hose on it, and instead of maybe a 1-inch hose, maybe you put a 1/4-inch hose on there. And what happens to the water? You put it into the same faucet, and you turn it all the way on, and what happens? That water shoots out. Whoosh! There's a ton of pressure. But it's the same amount of water. How come there's more pressure? Because there's more resistance. So once again, it depends on your arteries. This is where if we have coronary heart disease and we have more resistance in that these arteries have got plaque or cholesterol buildup, then we have less area it can go through. We have more resistance. Resistance is prevention of the flow of the blood. So if we have more resistance, we're going to have what? Higher blood pressure. Okay, now. All right, so let's move on there, okay? So which are the first vessels to branch off of the aorta, okay? So once again, we have the diagram that we're talking about. When we talk about the aorta, the first vessels to branch off are the coronary arteries, all right? The coronary arteries. And, man, once again, I could go on and on and on, but let's keep moving. The coronary arteries and well, let's just keep going. But let me say this about the coronary arteries. When it branches off, and you have these 2 big coronary arteries in your neck that go up to your brain, I want to tell you that 80% of all the blood that you pump out of your heart goes to your brain. 80% of all the oxygen that you need goes to your brain. Isn't that amazing? So we're sending a vast amount of blood up into our brain, about 80%, about 20% into the rest of the body. So those coronary arteries are critical. Okay. Now, let's fill in a blank here. Okay. Freshly oxygenated blood enters the heart through the left atrium. Okay. So freshly oxygenated blood coming directly from the lung enters the heart through the left atrium and is pumped out the aorta. Okay. So once again, freshly oxygenated blood enters the heart through the left atrium and is pumped through the aorta. Now once again, you have had a bunch of this stuff in the practice questions and going through your chapters. So a lot of this is kind of a review, and we're not going through the whole parts of the heart, but that's critical. Okay. The freshly oxygenated blood enters the heart through the left atrium and is pumped out through the aorta. Now someone suffering a heart attack in his or her anterior lower right ventricle probably has a blockage in which coronary artery. Okay, so now we're giving you an example. All right, so now we're giving you an example. We can look at which part of the heart based on where the blood comes in and where the blood goes out. Okay, so we can say, okay, if we have a blocked artery here, this is what's going to affect it, because we know which artery and which vein goes into that part of the heart, and we know where the blood goes into the heart and into this chamber and into that chamber. There's a system that it goes. So if someone is suffering a heart attack in the anterior lower right ventricle, then they have a blockage in which coronary artery? The anterior and interventricular artery. Okay, it's the anterior and interventricular artery. The anterior interventricular artery. Okay, and that was in, I think, your practice questions as well. Now, blood can come from cardiac muscle. Okay. All right. Now, here's another one. Okay. Boy, I just want to keep elaborating on all of these, and I've got to keep moving. Okay. Here's the question. Blood from the cardiac muscle itself drains into the what? All right. Okay. Now let's think about what we're asking here. Okay. All right. Blood from the cardiac muscle itself drains into and the answer is the coronary sinus. Okay, the coronary sinus. Now, this is kind of represented in the picture you have. The word sinus is an opening. Okay, we have sinuses up back behind our nose. We have sinuses all throughout our body, but the sinus is an open cavity. The sinus is an open cavity. So the blood from the cardiac muscle drains into the coronary sinus. Okay. Now let's talk about this one. The mitral valve. Mitral valve, P-R-O-L-A-P-S-E, prolapse. Okay. Now let's talk about, in case you don't know what a prolapse is. Once again, I start these terms and then I've got to kind of fill them in. Human anatomy is so many terms. Prolapse means that something shrinks, something caves in. Okay. So if a valve has a prolapse on that valve that's ordinarily opening and working, okay, all right. So in this case, we're talking about a mitral valve. Whenever we have a prolapse, then it goes back up into. Okay. See, here's this pressure coming in on this mitral valve. A prolapse means it comes back into, it sinks into. All right. So let's listen to the question. Mitral valve prolapse is a condition which causes blood to flow into the what? Okay, into the what? Now, let me give it to you again, and I know it's kind of tricky. You know, it was kind of nice when we were able to write everything on the board, but we would just be stopping every second and writing this on the board. Mitral valve prolapse is a condition which causes blood to backflow. Okay, causes blood to backflow into the left atrium. Now, why is this a problem? Okay, why is this a problem? So here's this mitral valve. What does a valve do? A valve lets blood in, but stops it from going backwards. Okay, so we've got this tricuspid valve. Okay, that has three different parts here. Okay, and as it opens up, it lets the blood in, but then it shuts quickly. Okay, and it doesn't let that blood go backwards. Doesn't let that blood go backwards. Okay, it doesn't let it reverse directions. All right. So what happens when we have a mitral valve prolapse, it means that that valve is come back up and it's sunk in here. So now what's happening? It's letting that blood go backwards. And obviously we have a real problem with this, because then as that blood goes out, okay, the new chamber that's supposed to receive blood does what? Well, it's already full of blood, so it has no place for that new blood to go in. The blood that was supposed to be pushed out, remember we were talking about this in the first video, what does the heart do? It's trying to get the balance between blood in and blood out. And with every beat of your heart, an amazing organ. I'm not even gonna tell you. There must be a creator again. Okay, you probably figured that out. But the heart's an amazing deal. Pumps, billions and billions of times in your lifetime, and every time it beats, the right amount of blood's got to go in and the right amount of blood's go out. So if we have a mitral valve that prolapse, then that's a problem, because then the blood is draining back into the compartment of the left atrium, and so it's not allowing new blood to go in. Okay, let's get a couple more here. Which of the following contains blood with relatively high oxygen content? Okay, so which part of the heart has a blood that has the high oxygen content? Well, those are the ventricles. So it would be the right and left ventricle have relatively high oxygen content. The ventricles have the blood that has just been oxygenated from the lungs. Okay, so the right and left ventricle. Now, all right, now how about blood with relatively low oxygen content? That's the pulmonary artery. Okay, the pulmonary artery. All right. Now, what's weird is in the heart, we always know that we have arteries and veins, and what arteries are supposed to be oxygenated blood. So we send this oxygenated blood throughout our body, and then we bring it back through veins. Well, but in the heart, there's a crossover. That's why they ask you this question, okay? All right, so once again, the question is, which of the following contains blood with relatively low oxygen content? And it's the pulmonary artery. And you're like, well, shouldn't it be the pulmonary vein, because that means that it has less oxygen? No, the pulmonary artery is got the blood coming in from the body, but it's still headed to the lungs. So this is the blood with relatively low oxygen content, pulmonary artery. Now, which term indicates that tissue in the heart has died? Okay, so what if we have muscle tissue in the heart that's died? Well, it's really critical of where that muscle tissue is, if it's in the atrium, or if it's in the ventricle, or if it's in the pericardium. But the term is, okay, it says what term indicates tissue in the heart has died, and the answer is INFARCTION, okay? It's in infarction, okay? All right? Say that word 10 times real fast. But it's INFARCTION, which is telling us that some of the heart, the heart and muscle tissue has died, okay? Very significant. We got to know where that is and how to adjust the heart. Well, let's do one more before we wrap up this one. Which term refers to the severe chest pain event during an attack of the myocardium ischemia? And so this is angina, A-N-G-I-N-A. And you may have heard this, commonly known as heartburn, okay? But what is happening here, it says it's a severe chest pain, okay, evident during an attack of the what? Myocardial, I-S-C-H-E-M-I-A, ischemia. So what that means is that the muscle of the heart itself is having to overwork itself. It's having to work beyond its deal. It's having to push extra hard. We have a bad combination between blood in and blood out. So all of a sudden you begin to get heartburn. Well, why might we get heartburn with diet? Well, we might eat something really spicy and you're like, well, I think I've got this heartburn because it's something I ate. Well, what happens is there's certain things that affect the heart muscles, as even things within our diet, because what this is absorbed into our bloodstream. So it's kind of interesting, because there's certain things within our diet that we really weren't made to eat. We eat them because we like the taste or whatever, but a lot of real spicy foods actually inhibit some of the muscles in our heart and give us what's called heartburn. So it's kind of ironic that we eat some things that really aren't really all that good for our bodies. I mean, I guess that shouldn't be too crazy. I mean, some people even smoke, and I don't think we're made to have smoke going through our body. But and angina can be caused from smoking as well. But angina, once again, is a severe